Alright, in this video we're talking about topic 14 from the Algebra 2 CFE review, which is about solving quadratics with complex solutions. Remember, complex solutions mean imaginary numbers, so we're going to be using the letter I. So I, remember, is the square root of -1. It's an imaginary number. First step is question 46. It's asking us to solve x squared minus 2x plus 3 equals 0. If you tried to factor that, you would be looking for two numbers that multiply to positive 3. They have to be the same sign. The only factors of 3 are 3 and 1. And if they're the same sign, they're either going to add to positive 4 or negative 4. But the b value here is -2. So factoring will absolutely not work to solve this problem. And if we can't factor a quadratic, our next jump is to the quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac over 2a. So let's go ahead and use that formula to fill in the blanks over here. X is going to equal -b. b is -2, so we're going to have a positive 2 here, plus or minus the square root of b squared, -2 squared, minus 4 times a is just 1, times c is positive 3, over 2a is just 1. Now if you try typing this in your calculator for it to solve it for you, it will give you an error because the calculator cannot do imaginary numbers. We're going to have to solve this one on our own. So let's go ahead and start simplifying here. 2 plus or minus the square root. Let's take a look at what happens inside the square root. -2 squared is just 4, minus 4 times 1 is just 4, times 3 is 12 over 2. And this is where the error comes from in your calculator, because 4 minus 12 is -8, and this is asking us to do the square root of -8. And that's why it's having such a hard time. So if we want to simplify this by hand, what we're going to do is we're going to take the square root of -8, this guy here, and we're going to simplify this. The square root of -8, I'm going to break that down into pieces. That's the square root of -1 times 8. And I want to see if I can simplify the square root of 8. 8 is 4 times 2. 4 is a perfect square, and I can take the square root of -1 if I use an imaginary number. So I'm going to bring both of those out of this radical. The -1 comes out of the radical as I. The square root of 4 comes out of the radical as 2. And this 2 over here is going to be stuck inside. So that's the square root of -8 simplified. 2i times the square root of 2. And I'm going to go ahead and fill in the rest of my formula that I had before. 2 plus or minus out front, and this divided by 2 on the bottom. So we're almost finished with this problem. The very last thing I want to do is simplify, and this can be simplified just a little bit. You'll notice that this plus or minus separates these two terms. Both of them have a 2 in them, and we're dividing by 2. So I'm going to divide everything in this fraction by 2. 2 divided by 2 is 1, and this 2 divided by 2 is 1. So x equals 1 plus or minus 1i, which is just I, times the square root of 2. So that's my final answer. It's either x is 1 plus I times the square root of 2 or 1 minus I times the square root of 2. And that guy's all done. Let's go ahead and take a look at this next one. Now again, we could use the quadratic formula for this, but there's a much easier way if you recognize that 36x squared is a perfect square and 25 is a perfect square. Now we already talked about how to factor difference of squares. All I have to do is figure out what's being squared in front. In this case, 36x squared is 6x to the second power. And what's being squared in back? 25 is 5 squared. If I was going to do difference of squares, I would just do a plus b times a minus b. But I don't have difference of squares. I have a plus sign. This is a sum of squares, which means all I have to do is put an I with my b term, and I'm done factoring. So let's go ahead and do that. We have this guy here. My a term is 6x. My b term is 5. I have a plus and I have a minus, and all I have to do is put I here, and I'm done factoring. It is asking me to solve, so I do have to set these equal to 0 to solve. So I have 6x plus 5i equals 0. I can subtract 5i from both sides, -5i, and divide both sides by 6. So x is -5i over 6. And I can do the same thing with my other factor, 6x minus 5i equals 0. I start by adding 5i to both sides, so positive 5i divided by 6, and I get x equals positive 5i over 6. So these would be the two answers to my quadratic, both imaginary. We have one more to work on here, the complex zeros of the equation. So it's already telling me this can't be factored. It's telling me that I have to find imaginary numbers, which means in this case, since I don't have a special case happening, it is easiest for me to just go ahead and use that quadratic formula again. So x equals the opposite of b, which is going to be a positive 3, plus or minus the square root of b squared, negative 3 squared, minus 4 times a, which is just 1, times c, which is 9, all over 2 times a. A, again, is just the number 1. Again, the calculator can't help you with this one. You're going to have to simplify it by hand because we already know it's going to be complex, and your calculator can't do imaginary numbers. So let's take a look here. X equals 3 plus or minus the square root. Let's simplify in here. Negative 3 squared is positive 9. Minus 4 times 1 is just 4, times 9 is 36. So 9 minus 36, that's absolutely going to be a negative number. 2 times 1 in the denominator is just 2. So let's simplify that radical. 9 minus 36 is negative 27. So 3 plus or minus the square root of negative 27 over 2. Now I want to simplify that square root of negative 27. So I'm going to take this radical here, and I'm going to simplify it off to the side. The square root of negative 27 can be broken down to the square root of negative 1 times 27. And 27 is 9 times 3. 9 is a perfect square, and negative 1 can be taken out of the radical using imaginary numbers. So if I bring the negative 1 out, I get I. If I bring the 9 out, I get 3. And this 3 is going to be stuck inside my radical. And then we can fill in the rest of the stuff we had originally. 3 plus or minus this number over 2. That's what x is going to equal. Now I have a 3 in front of my plus or minus, and I have a 3 here, but the number I'm dividing by is just the number 2, so there's nothing I can actually simplify here. So my answers are either 3 plus 3i root 3 over 2, or 3 minus 3i root 3 over 2, and that question is done, which means that we are finished with topic number 14 from the review.